Today we will discuss about the stiffness effect on this oncogenic promoter. In the previous video we have seen that with increasing the stiffness there is an increase in the EMT, that is epithelial-to-mesenchymal transitions, and that we have seen maximum changes in the cell lines which is more epithelial in nature, that is BXPC3 among the three cell lines that they have used. Here they have gone one step further to check whether it will increase the oncogenic promoter, which in turn also affect the EMT, that is epithelial to mesenchymal transitions. So what promoter that they have checked is YAP and TAZ. Before moving further, how this works is that in epithelial conditions, this YAP and TAZ are usually remains in the phosphorylated conditions that prevents this YAP and TAZ to localize from cytosolic region to the nucleus region. However, in the case of this mesenchymal conditions, what happens? The dephosphorylations of this YAP and TAZ promoters occurs, and they will lead to the nuclear localizations, and that will cause the epithelial to mesenchymal transitions. So they wanted to check whether these oncogenic promoters will also be affected with different stiffness, or as with increase in the stiffness, these oncogenic promoters will more lead to nuclear localizations or not. So when they check it for the YAP, the immunofluorescence image shows that with increase in the stiffness, the nuclear localizations increases, and for all the three cell lines. However, the relative increase is more for the BXPC3, as its baseline stage is epithelial in nature, whereas ASPC1 is less epithelial compared to the BXPC3, and SUT2007 is already mesenchymal in nature. And this red fluorescence is the palladian staining, just to show how the cells looks like at how the cells look like at high stiffness. And when they quantified these results in the panel B, we can see that the increase is more for the BXPC3 cell lines compared to the ASPC1 or SUT007. However, the increase is in the high stiffness case, the increase is statistically significant for all the three cell lines compared to the lowest stiffness polyacrylamide gel, that is 1 kilopascal. Afterwards, they did the similar studies for the another oncogenic promoter, that is TAZ, and it also works in a similar way. That with increase in stiffness, the nuclear localizations increases, and this increase is more for the BXPC3, as we have seen for the YAP, compared to the other two cell lines. And these things are also quantified in the panel C, where we can see that the increase is statistically significant and even more compared to the increase in the other two cell line cases for this percentage TAZ nuclear localizations. Thereafter, they also checked one of the genes that are related to these YAP nuclear localizations, that is CTGF and ANKRD1, and they are able to see that these genes are also increased. These genes are also increased with increase in the stiffness. For CTGF genes increase with increase in the stiffness, which is statistically significant. However, the increase of this ANKRD1 is increased, but these are not statistically significant. And this results is for the BXPC3. So from this results, from the results that they have seen in the previous figure or the previous experiments, they come to a point that with increasing the stiffness, it will promote the oncogenic promoters, and these oncogenic promoters might lead to the epithelial to mesenchymal transitions and other oncogenic favorable conditions. So I hope you understood how they validate these stiffness relations with this oncogenic promoter. If you need to understand more about these experiments in detail, you can go through the reference that has been provided in the descriptions. And before we end, the penalty results are of this mRNA, and they have used the qPCR to analyze this CTGF and ANKRD1. So thank you for your time.